Hello, welcome to Unit 2 of Physics 1. I hope you did your test 1 well. Let me know if you have any questions or concerns. We will start Unit 2 by looking back at Unit 1. What did we do in Unit 1? We discussed the case of particle motion. We talked about displacement, velocity, acceleration, and so on for particles that are in motion. Therefore, in this unit, is it reasonable that we ask the question, what is it that makes particles move? What is responsible for making things move? Well, you notice that there is a car here which is at rest, and it is going to sit there at rest as long as there is no net force on it. Now, the moment I apply a net force, the car will move. So tell me, what is responsible for making an object move? An object moves when there is a net force acting on it. How about if that object is already in motion? If an object is already in motion, it will continue in that state of motion unless there is an unbalanced force acting on it. That means the state of rest of an object or the state of uniform motion of an object can be changed only and only if there is an unbalanced force acting on the object. Now, what is the meaning of unbalanced force? Now, when I take this mass on the scale here, this mass now has no unbalanced force. It has a force, the earth is pulling it with a force, and I'm holding it with the same force. Now, there is no unbalanced force. Why? Because the force with which the earth is pulling it is balanced by the force with which I am supporting it. Now, the force I am supporting it is upward. The force the earth is pulling it downward. And here the forces are balanced. The moment I let it go, I am no longer supporting it. There will be an unbalanced force. And there it falls. The unbalanced force made it move. So, you need to understand the meaning of an unbalanced force. Okay, that means it is an unbalanced force that sets an object in motion. You have an object here, an unbalanced force will make it move. An unbalanced force acting on an object in motion will change its state of motion. If you watch people play soccer, a soccer ball coming towards a player is in a particular state of motion. In other words, it has a certain speed in a certain direction. Now, have you seen players heading the ball into the goal post? What the person is doing is applying a force on a moving object to change its state of motion. So a moving object will continue in its state of motion unless there is an unbalanced force. An unbalanced force acting on a moving object. Now here you saw the object moving from the left. Well, I don't think you can see it. It is moving from the left, and unbalanced force now changes its state of motion. Alright, so an unbalanced force changes the state of rest of an object or it changes the state of motion of an object. And this statement is called the first law of motion. So how can you define the first law of motion? We can say an object will remain in its state of rest or in a state of uniform motion unless an external unbalanced force acts on it. An object remains in its state of rest or in the state of uniform motion unless acted upon by an external force. It is an external force that is responsible for either putting an object in motion or changing the state of motion of an object. Now, a force is a vector quantity. It has both magnitude and direction. You see, we haven't defined force yet, have we? Do you know what a force is? How do you define? You know that a force can be used to bend objects. A force can be a pulling or a pushing. You can see all kinds of things you can do with force. If I ask you to give me a definition of force, what would that be? We can actually use this statement to define a force. I can say a force is something that will change the state of rest of an object, or force is something that will change the state of motion of an object. Well, if you put it together, we have a definition of force. And you know force is a vector quantity. Why is force a vector quantity? Because a force has both magnitude and direction. Now, if I told you I applied a 50 Newton force on this mass. Now, did you understand what that 50 Newton force is? I can push the mass up, I can pull it down, I can lift it, I can squeeze it. You see, unless I mention the direction in which the force was exerted, you did not understand what that force actually did. So force, the description of a force is not complete unless its magnitude and direction both are specified. That means force is a vector quantity. And all the rules for vector addition is used for adding forces. And we will be using that in this lesson. Adding forces. We will use the rules for vector addition. So have you defined force? What is therefore force? Force is something that will change the state of rest of a particle or change the state of uniform motion of a particle. Let's now talk about the concept of inertia. What does inertia mean? It is something that we normally use in our daily life. Is that right? It's a common vocabulary word, inertia. Or that person has immense inertia. Means it is very difficult to get him to do something. It is very difficult to change him. If he is doing something, he wants to keep on doing that. If he is sleeping, he wants to keep on sleeping. You see that? That person has great inertia. In the absence of an unbalanced force, an object at rest will continue in that state of rest. An object in motion will continue in that state of motion. Isn't that inertia? Yes, an object at rest would want to continue being at rest. An object in motion would want to continue being in motion. And that is what we call inertia. Now, this property is what we call inertia. Now, since Inertia is a tendency to resist the change of rest. Now remember, if I want to change the state of rest of this object, I need to apply a force on it and lift it. And remember, when it is at rest, its velocity is zero. The moment I move it from its rest position, I am changing its velocity. And you know, when the velocity changes, there is acceleration. That means whenever an object at rest changes its state of rest, an acceleration occurs. Similarly, whenever an object in motion changes its state of motion, an acceleration occurs. So, if inertia is the tendency of an object to resist change, changing from the state of rest or changing from the state of motion, we can say inertia therefore is a tendency to resist acceleration. The tendency of an object to resist acceleration is called inertia. Okay, that is a good definition of inertia. And therefore the first law of motion is also called the law of inertia. The first law says the tendency of an object to remain at rest or remain in the state of motion will continue unless there is a net force acting on it. So the state of inertia can be broken only by a net force. Is that right? You know, if you have kids, the only way to break the inertia of the sleep of a kid is to use a net force, pull the cover or do something to get him up. Well, that is not really what we're talking about here. Now, law of inertia, which is the first law, helps us to define force. And what is the definition of force that we have been talking about? Now, a force is something that changes or tends to change the state of rest or of uniform motion of an object along a straight line. So the first law of motion, which is the law of inertia, helps us to give a definition of force. Now, if somebody asks you, what is a force? You can now give an answer. Can you give me an answer? What is the definition of force? Force is something that will set an object into motion or change the state of motion of an object. Without a force, you cannot do that. All right. Now, watch here an illustration of inertia. Why does that ladder fly off from that truck? Well, because the ladder has been in a state of motion and suddenly the truck is brought to a stop. The ladder doesn't want to stop because the law of inertia says if something is in motion, it wants to keep on being in motion. So the ladder that is moving would want to keep on moving. This is an example that is very familiar to you. Look at this one. Some of you must have experienced this. If you are on a motorbike and the motorbike is suddenly brought to a stop by something, well, you have been moving with the motorbike. If the motorbike is brought to a stop, you are going to continue moving. This is a good example of inertia. Why does the man behave like this? Because he wants to keep on moving. And that is inertia. Well, one more example. I know you are tired of these examples. All these are familiar examples. When the car is suddenly brought to a stop, the man who is not wearing a seatbelt will want to continue moving. He wants to obey the rule of inertia.